We continue our lesson. For example, 5.21. A function f is given by fx equal to x squared minus 4x plus 1. If the domain of f is set of all real numbers, show that the function f has no inverse. And restate the domain so that fx is one-to-one function. To solve this question, we can choose first method, sketch the graph, and to prove that f has no inverse, that means f is not 1 to fx equal to x squared minus 4x plus 1. The value of a equal to 1, b negative 4, and c equal to 1, and a greater than 0. The function is minimum. Find the minimum point. X equal to negative b over 2a equal to negative times negative 4 over 2 times 1 equal to 2. And the value of y, substitute the value of x into the function. 4 minus 8 plus 1 equal to negative 3. Therefore, the minimum point at 2, negative 3. And intercept y-axis at y equal to 1. Refer the value of c. We sketch the graph quadratic. Y-axis, x-axis, and the minimum point at 2 and negative 3. And intercept y-axis at 1. To prove that the function is not one-to-one function, we can draw one horizontal line, y equal to k. The k is any value. Therefore, the graph is intercept y equal to k at 2 points. At x equal x1 and x2. Therefore, this function is not one-to-one function. Therefore, shown the function f has no inverse. Next, how to restate the domain so that f is not one-to-one function. To restate the domain, we refer at the symmetrical line. Draw one symmetrical line. That symmetrical line, x equal to 2. Therefore, to prove that fx is one-to-one function, therefore fx equal to x squared minus 4x plus 1 and x greater than or equal to 2. For example 5.22, the question is, a function f is defined by fx equal to set x minus 1 and x greater than or equal to 1. Find an expression for f inverse and find the domain and the range of the f inverse. To solve this question A, fx equal to set x minus 1 and x greater than or equal to 1. To find f inverse by using the properties. F composite f inverse equal to x. Now, the input of fx is f inverse. Set f inverse minus 1 equal to x. F inverse x minus 1 equal to x squared. And f inverse x. To state the value of x, we can refer the function x greater than or equal to 1. That means fx is set 1 to 1 equal to 0. Therefore, fx is greater than or equal to 0. For f inverse equal to x squared plus 1 and x greater than or equal to 0. The y switch to the x. And question B, find the domain and the range of the f inverse. Domain of inverse equal to from 0 to infinity. And the range of the f inverse equal to the domain of the function. Therefore, from 1 to infinity. For example, 5.23, the function f and g are defined by f that x map to 2x plus 3 and g that x map to x minus 1. Find question A, f inverse and g inverse. Question B, g composite f inverse. And question C, f inverse composite g inverse. For question A, f composite f inverse equal to x using properties. So, 2 f inverse plus 3 equal to x, 2 f inverse equal to x minus 3 and f inverse equal to x minus 3 over 2. Next, for find g inverse by using properties, g composite g inverse equal to x. Therefore, g inverse minus 1 equal to x and g inverse equal to x plus 1. Question B, find f composite f inverse. First, find g composite f. G and the input of g is fx equal to fx minus 1 equal to 2x plus 3 minus 1 equal to 2x plus 2. To find f composite f inverse, we using the properties. G composite f composite g composite f inverse equal to x. That means the input is f composite f inverse. 2 g composite f inverse plus 2 equal to x. 2 g of f inverse equal to x minus 2 and g composite f inverse equal to x minus 2 over 2. For question C, find f inverse composite g inverse. F inverse composite g inverse. The input of f inverse is g inverse equal to g inverse minus 3 over 2. Refer the f inverse. Now, g inverse is x plus 1. X plus 1 minus 3 over 2 equal to x minus 2 over 2. We can write f inverse composite g inverse is equal to g of f inverse. Okay, that's all. Thank you. Okay, we continue our lesson for sketch the graph of the function and its inverse. Refer from the graph, the red line is the graph fx. Intercept y-axis at A and intercept x-axis at B. And the dotted line blue, y equal to x, is called the reflection line or the symmetrical line. And the yellow line is the inverse function. Therefore, when the function f intercepts y-axis at A, therefore reflection is at x-axis at A. From coordinate 0A to switch to A0. And at B, the coordinate is B0 to switch 0B. That means the value of x and y are switched each other for inverse. The graph of y equal to fx and f inverse x are reflect of each other in the line y equal to x. For example 5.24, for each of the function below, sketch the graph of f and f inverse on the same x. State the domain and range of f inverse. Given fx equal to 2x plus 5, that's a linear function. Intercept y-axis at 5. And the gradient is 2. M equal to 2. When y equal to 0, 2x plus 5 equal to 0 and x equal to negative 5 over 2. That means intercept x-axis at negative 5 over 2. Now we can draw the straight line. And label is fx. Now we draw the dotted line. The dotted line is a reflection line. Y equal to x. And we can reflect the inverse. When the graph is intercept y-axis at 5, that means reflect to intercept x-axis at 5. When intercept x-axis at negative 5 over 2, reflect to intercept y-axis at negative 5 over 2. Okay, draw the graph inverse. F inverse x. Now state the domain of the F inverse. Refer the green line. The domain of inverse function is the linear green line. The negative infinity to infinity. And the range of the F inverse also from negative infinity to infinity. For example B, fx equal to x minus 9 squared and x greater than or equal to 9. The form of completing the square is fx equal to a x minus h squared plus k. The minimum or maximum point at hk. For question B, the minimum point at 9, 0. We can sketch the graph minimum point. X-axis, y-axis, and intercept x-axis at 9. And the graph is concave up. The next step, draw the inflection line. X equal to y or y equal to x. And we reflect when fx intercept x-axis at 9, the reflection is intercept y-axis at 9. And draw the graph inverse f inverse x. Therefore, the domain of the inverse function is from 0 to infinity, and the range of inverse equal to 9 to infinity. For question C, given fx equal to set x minus 2 and x greater than or equal to 2. That is the set function. First, state the starting point. The starting point for x minus 2 equal to 0, x equal to 2. And the value of y is substitute the value of x into the function. Set 2 minus 2 equal to set 0 equal to 0. That means the starting point at 2, 0. And the set is positive. We can sketch the graph set. X-axis, y-axis, and the starting point at 2, 0. And the set is positive. Fx. Next, draw the inflection line or symmetrical line y equal to x. Now we can reflect at 0, 2. Here is the inverse function. Therefore, the domain of the inverse function is 0 to infinity, and the range of the inverse function is 2 to infinity.